Today, we will focus on the outline selection of medium voltage VFDs. Before we begin, let's briefly review the drive system. A drive system primarily consists of the power supply, the VFD, the motor, and the load. As the diagram shows, the VFD's input connects to the power grid, and its output connects to the motor, which drives the load. Therefore, these three components are the primary factors influencing its selection. Additionally, the VFD's operating environment and the project budget must be considered. For example, the voltage of the power supply determines the VFD's input voltage. The motor's rated voltage and rated current determine the VFD's rated output voltage and rated output current. The load type, speed range, and required control precision determine the VFD's control mode, overload capacity, and functional configuration. The load's duty cycle determines the reliability requirements for the VFD. The altitude affects the VFD's cooling and insulation, among other factors. A cascaded H-bridge MV VFD primarily comprises a phase-shifting transformer, multiple power cells, and a control system. The main functions of the phase-shifting transformer are stepping down the voltage, phase shifting, and providing isolation. The main function of each power cell is to perform rectification, filtering, and inversion. Multiple low-voltage power cells are connected in series and star connected to directly output a medium voltage. The main functions of the control system are control, protection, and integrated communications. Essentially, selecting our MV-VFD involves choosing these three key components. Key parameters for the phase-shifting transformer include its cooling method, capacity, and primary or secondary voltages. Key parameters for the power cells include their cooling method, voltage, and current ratings. Key configurations for the control system include whether redundancy is required and if process control functions are needed. The selection criteria are as follows. The transformer's cooling method depends on its capacity, reliability requirements, on-site environmental conditions, and budget. Its capacity is primarily determined by the motor's rated or starting power, load's overload characteristics. The primary voltage is determined by the grid voltage. The secondary voltage and number of secondary windings are determined by the cell voltage and the required number of cells. The power cell's cooling method depends on the motor's rated or starting current, reliability requirements, on-site environmental conditions, and budget. Its rated voltage depends on the cooling method and the motor voltage. Its rated current depends on the motor's rated or starting current, site conditions, and the load's overload characteristics. The number of cells depends on the motor voltage and the cell voltage. The need for redundancy in the control system depends on reliability requirements. The need for process control functions depends on the load type. For example, loads like rolling mills or grinding mills typically require the VFD to have specialized process control capabilities. To summarize, the main factors considered when selecting components for a VFD are the power supply conditions, the motor, the load, the environmental conditions, and the project budget. Based on these core factors and combined with any other specific project requirements, auxiliary functions can then be configured.